Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about how to show the given functions are bijective or not. In our previous classes, we clearly discussed what is meant by bijective functions. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, so we do multiple examples. So hoping that you already know what is meant by one-to-one and onto function. Let's take this function, show that a given function R to R, it means real numbers to real numbers, means domain is real number and codomain is real numbers. So hoping that you already know what is meant by domain and what is meant by codomain. So defined by the function f of x is given as 2x plus 1 is bijective or not. So if you want to show that it is a bijective function, you should show that it is one-to-one function and it is onto function. So how we are going to show that the given function is one-to-one or not? Let's refresh the concept of one-to-one. One-to-one means this is domain and this is codomain, real numbers, real numbers. Different numbers, different elements in the domain should have an image in different images in codomain. So different elements in x should map to different elements in y. Then only it is one-to-one function. So how we are going to show that? Let's take f of x, f of y. Means f of x means we are taking element x, f of y means we are taking element y. Element x belongs to x codomain, element y belongs to this element x belongs to domain and element y belongs to domain. F of x means you are going to get the element here. That is what f of x says. F of x is equal to 2x plus 1. Means if you take element here, the mapping you are going to get using f of x. If you take element here, the mapping you are going to get here using f of x. So we have taken two elements, f of x, f of y. Assume that if f of x is equal to f of y, then definitely what should happen? X equal to y should happen. Then only we can say that it is one-to-one function. What's the meaning of that? F of x means the image here, f of y means the image here. If you assume that these two are same, then these x and y should equal. Otherwise it is not one-to-one function, because otherwise it is two different elements is having same image in codomain. So that's why if you show that, if you take f of x equal to f of y and if you show that x equal to y, then it is one-to-one function. So f of x is equal to 2x plus 1, f of y is equal to 2y plus 1, 2x is equal to 2y, 1 cancel, x equal to y. So from this we have showed that x equal to y. So how we got that f of x is equal to 2x plus 1? Because the function is given that 2x plus 1. F of y means 2y plus 1. If you assume that f of x is equal to f of y means the same element here, then x and y should be equal. Otherwise it is two different elements is having the same image, which is not accepted in one-to-one function. Okay, so this is how we need to show it is one-to-one or not. The function is one-to-one or not. Now coming to show that onto function, f of x equal to y. So what is meant by onto function? Every element in the codomain, this is codomain, every element in the codomain should have a pre-image in domain. Then we can say that it is onto function. How we are going to show that the given function is onto or not? Take f of x is equal to y, 2x plus 1 equal to y, x is equal to y minus 1 by 2. So y minus 1 by 2, y minus 1 by 2 belongs to R. R means real numbers, which is a element in domain. So what is our domain says? Real numbers to real numbers. Y minus 1 by 2 is a real number. Means for any value you take here in the codomain, you are going to have an pre-image in domain. So every element in codomain will have a pre-image in domain. So this is what we had showed here, f of x is equal to y, so that y minus 1 by 2 belongs to domain. If you showed like this, then we can say that it is an onto function. So the given function f of x is equal to 2x plus 1 is a one-to-one and onto function. So it is called it as a bijective function. We take one more example for better understanding of the concept. Take the second example, f from z plus to z plus. Means z plus means only positive integers. Domain is only positive integers, codomain is only positive integers, and the function f of x is equal to 3x. Is it a bijective function? No, it is not a bijective function. We need to show that it is one-to-one and it is onto. If you show that, then it is a bijective function. But let's try to show that both one-to-one. How we are going to show? F of x is equal to f of y. 3x is equal to 3y. X is equal to y. So it is a one-to-one function. Similarly, we need to show that it is an onto function, but it is not an onto function. Why? Because let's take element 5 belongs to z plus. Means 5 belongs to positive integers. Means 5 is an element in codomain. So f of x is equal to y. 3x is equal to 5. So y is the element in the codomain, we consider it as 5. So 3x is equal to 5. X is equal to 5 by 3. 5 by 3 is an element that does not belongs to z plus. So x is equal to 5 by 3 means 5 by 3 is the value that is not present in the domain. What is our domain? Z plus. Z plus means only positive integers. It is a real number. It is not an integer value. 5 by 3 means floating point value you are going to get, which is not the image that present in the domain. So for every element in codomain, you should have any pre-image in domain. So for the element 5, you do not have an image in x in the domain side. 5 is an element in codomain which is not having an image in domain. So it is not an onto function. So similarly, take the next one. Third example, function real numbers to real numbers. You take a domain is real numbers, codomain is real numbers. F of x is equal to x square. Is it a bijective function? No, it is not a bijective function. So if you want to show it as bijective function, one-to-one and onto you must show. One-to-one means f of x is equal to f of y. X square is equal to y square. You cannot cancel these squares because x is equal to plus or minus square root of y square. That is how you have to show. So x equal to y, you cannot say that. So you are not able to show that x equal to y. So it is not a one-to-one function. Similarly, we try to show whether it is onto function or not. So if you want to show it as onto function, what's our domain and codomain says? Real numbers to real numbers. Let's take y is equal to minus 1. So y is a value that present in codomain which is minus 1. F of x is equal to y. X square is equal to minus 1. X is equal to plus or minus square root of minus 1. Means plus or minus 1 means I. It is an imaginary number. It is not a real number. So plus or minus I, not a real number. So for minus 1, we don't have an image in domain. Minus 1 is an element that present in codomain which is not having an image in domain. So it is not an onto function. So this is how we need to show the given functions are one-to-one and onto. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.